Hi guys, today we're going to be talking about polygons. So let's get right into it, okay? We already talked a little bit about triangles in the last couple of days and quadrilaterals, but today we're going to look at objects that have more than 3 or 4 sides. So basically any object with 3 or more sides is considered a polygon, and we usually say we use n for the number of sides. Okay, all of the lines have to be line segments, and some of the common polygons are a triangle, as we've seen, with 3 sides, quadrilateral with 4 sides, and then you can have a square that's a regular type of quadrilateral. A pentagon has 5 sides, and a hexagon has 6 sides. Okay, now the other thing I should say is that all of the line segments have to be have to touch. Okay, so you can't have something like like that, and then there has to be a closed shape for it to be a polygon. Okay, so let's look at some of the interior angles of the polygon, and we already know that that the interior angles of a triangle add up to 180 degrees. Okay, but what about shapes that are what about polygons that are more than 3 sides? So what about a quadrilateral? Well, if we have a quadrilateral, again, that's a 4-sided figure. Okay, and we draw what's called a diagonal right across the middle there. Okay, look what happens. We actually turn that quadrilateral into two triangles. So there's the first one and there's the second one. So if we know that each triangle has 180 degrees, that means that if these 3 angles add to 180 degrees over here, and these 3 angles here add to 180 degrees, well, that must mean that that all the angles in the quadrilateral must add up to 180 plus 180, okay, which is 360. So basically, it doesn't matter what quadrilateral shape you have, the angles are always going to add up to 360, which is 180 more than for a triangle. Okay, what about if we have a pentagon? Okay, so there's a pentagon. Okay, and again, that's a 5-sided figure. And look what happens when we draw a couple of diagonals in the pentagon. We actually what we end up getting is 3 triangles. So there's one triangle, there's the second triangle, and there's the third triangle. So if all the triangles have 180 degrees, well, the pentagon, the sum of its internal angles, so 1, 2, 3, 4, and 5, are going to add up to whatever 180 times 3 is, which is going to be 540, which is 180 more than for the quadrilateral, and it's twice as much as or 360 degrees more than the triangle. So there's actually a pattern here that you've probably figured out already, and there's actually a formula, and the formula says something like this. So the interior angles of a polygon equal to n minus 2 times 180, and the n in this case is just the number of sides for a polygon. So for this last example of the pentagon, okay, we had how many sides? 5 for a pentagon. Okay, so it's going to be 5 minus 2. There's 5 minus 2 times 180, or 3 times 180, 540. So the formula is, again, is n minus 2 times 180. Nothing too fancy here. I'm sure most of us have kind of figured that out already. So let's see if we can answer this question. How many sides does a polygon have if its interior angles total 900 degrees? So they're asking us now they're asking us for the number of sides. How many sides? So we're looking for the n here. Okay, so if this is our formula here, so we have interior angles. If the interior angles add up to 900, n minus 2 times 180. Okay, so now we're actually looking for the number of sides, so we just have to solve for n, and we all know how to do that from our equations unit. So we're going to divide both sides by 180 to get rid of that 180. So 900 divided by 180, which is just 90 divided by 18, is going to equal 5. So 5 equals n minus 2. And then n equals 7 once we get that 2 over to the other side. So how many sides does a polygon have if its interior angles total 900 degrees? Well, it has 7 sides. So it might look something like this. 1, 2, 3, 4, 5, 6, and then finally 7, like that, okay? And that's called a heptagon, okay? And if we wanted to check, if we wanted to make a few triangles like this, 1, 2, 3, and 4 and 5, so 1, 2, 3, 4, and 5, and we would see that 5 times 180 equals 900. Okay, if we look at, let's look at some of a table here. So some of the names here. So again, the key thing is triangle has 3 sides, quadrilateral has 4 sides, pentagon has 5 sides, hexagon has 6 sides, heptagon, and then there's probably the octagon, which you kind of want to remember. So those first 8, you want to remember their names. Okay, now there's a special thing called a regular polygon. A regular polygon is a shape that all of the interior angles are the same. Okay, so in the case of a triangle, that's called an equilateral triangle. All of these angles are going to be the same, so all of them are 60. For a square or a rectangle, that would be a regular quadrilateral. Okay, those would be all 90 degrees. For a pentagon, okay, so for a pentagon, which is again all the angles add to 540, and if you divide that by 5, you will get 108. So all of these here are 108 degree angles. Hexagon is 120 if it's a regular hexagon, and then a heptagon. This one's not the one with does not have whole numbers, so it's 128.571. A little bit hard to remember that one. Okay, the octagon would have. Well, let's first see if we can come up with how many what the total for an octagon. So an octagon has how many sides? It has 8 sides. So our formula for an octagon would be n minus 2 times 180. So we're looking for an octagon. It has 8 sides, so 8 minus 2 times 180, and that would be 6 times 180. And so the octagon would have, which adds to 1080 or 1080. And if we took that 1080 and divided it by 8, we would get the measure of the internal angles, which is 135. And the octagon is the shape of a stop sign, which you've probably seen. Octagon. Okay. All right. Let's move on to exterior angles now. Exterior angles are not really the most intuitive ones because they're not actually. Some people might think an exterior angle would be something like this over here, but that's not actually it. The exterior angle, they're a little bit hard to draw at first. For example, if we had a triangle like this over here, okay, and if this was the interior angle, here's how the exterior angle is measured. It's the angle between any side of a shape and a line extending from the next side. So that's a little bit weird to think about. Okay, so if we had this triangle here, and if I extended this line over here, this here would be the exterior angle. Okay, so it's a little bit hard to imagine there. You're actually making supplementary angles here. So if the interior angle is 30, the exterior angle will be 150. Okay, and if this angle here is 90, the exterior angle here would also be 90. They're always going to add to 180 with the interior angle. Again, if this angle here is 60, okay, this angle here, the exterior one would be 120. All right, so let me give you a visual here so you can kind of get this here. So there are the exterior angles right here. We have in an equilateral, you just extend the lines, and these would be called the exterior angles. So These would be called the exterior angles up here. These would be called the exterior angles over here. Now there's a special thing with exterior angles. They're always going to add up to 360, and you can check that for any shape here. If we added 120 times 3, that's going to be 360. 90 times 4 is going to be 360. 72 for the pentagon times 5 is going to be 360. So it doesn't matter what the shape is. The exterior angles are always going to add up to 360. So that formula is pretty straightforward. If the question says what is the sum of all the exterior angles of a heptagon, you always know the answer is going to be 360. It doesn't matter what the polygon is. Okay, so thanks for watching and see you next time.